Question 14e. Two machines, A and B, produce pens. It is known that 10% of the pens produced by machine A are faulty and that 5% of the pens produced by machine B are faulty. Part 1. One pen is chosen at random from each machine. What is the probability that at least one of the pens is faulty? With problems involving probability, if the words "at least" are used in the question, it's generally easier to use complements in order to answer the question. So in this case, the probability that at least one pen chosen is faulty is equal to 1 minus the probability that no pens chosen are faulty. And that equals 1 minus 0.9 times 0.95. So this 0.9 corresponds with the probability that a pen chosen from machine A is not faulty, and 0.95 corresponds to the probability that a pen chosen from machine B is not faulty. And that equals 0.145. And expressing this value as a percentage, we have the probability that at least one pen chosen is faulty is equal to 14.5%. Part 2. A coin is tossed to select one of the two machines. Two pens are chosen at random from the selected machine. What is the probability that neither pen is faulty? It may help to represent the situation using a probability tree diagram. Firstly, there is a 50% chance of choosing machine A or machine B, assuming it's a fair coin, of course. Now, I've represented these probabilities as a decimal, so 0.5 chance of choosing A or a 0.5 chance of choosing B. Let's say we've chosen machine A. Now, there is a 10% chance that a pen chosen is faulty, but we want the probability that two pens chosen from machine A are not faulty. So it's going to be 0.9 times 0.9 or 0.9 squared. So to get the probability of choosing machine A and two pens that are not faulty, we just multiply these values along these branches. So it's going to be 0.5 times 0.9 squared. Now, if we've chosen machine B, the probability of choosing two pens that are not faulty is 0.95 squared. So to get the probability of choosing machine B and two pens that are not faulty is 0.5 times 0.95 squared. So to get the probability that no faulty pens from either machine are chosen, we just add these two probabilities together. So it's going to be 0.5 times 0.9 squared plus 0.5 times 0.95 squared, which equals 0.85625 or 85.625%.